We are starting chapter 21, and this chapter is on carboxylic acids. We are going to start with just a section on nomenclature. And this is really exciting because this is the last functional group that you are going to learn how to name. Like, this is it. This is the end of learning about nomenclature for you. So as a refresher, let's take a look at the carboxylic acid functional group. As you know, it's a carbon-oxygen double bond with an OH group directly attached, and then some sort of alkyl group on the other side of the carbonyl. Also in this chapter, we're going to study carboxylic acid derivatives. Although we aren't going to learn how to name the derivatives of carboxylic acids, we're only going to learn naming carboxylic acids. Your book covers the naming for the derivatives, so watch out. It is really not necessary for you to learn how to name the derivatives. So I'm going to draw the structure of the carboxylic acid derivatives. So the first one that I'm drawing here is the ester. And we also have, and I'm not drawing these in the order that we're going to study them. We also have this functional group, which is called the acid or acyl halide. When there's a particular halogen on there, like if it was a chlorine, we would call it an acid or an acyl chloride. We also have this guy right here, which is like a two carbonyl groups with an oxygen in the middle of them, and that is called an anhydride, sometimes called an acid anhydride. And then last but not least, we can have a nitrogen on the carbonyl group, and this is an amide. And it's important for me to point out, for pretty much all of these R's that I wrote, almost all of them could also be hydrogens. So this particular R is the only one that must be an actual alkyl group. If there is a hydrogen here at this point of the molecule, it's not an ester, it's just a carboxylic acid. But for all of the rest of the R's in these carboxylic acid derivatives, they could either be an alkyl group or they could be a hydrogen. And so in this chapter, after we learn how to name carboxylic acids, we are then going to go on to looking at the reactions of the carboxylic acids and their derivatives. So let's start with naming carboxylic acids. And by now I know you're really accustomed to the basic IUPAC rules, so we're just going to kind of abbreviate this. Your goal is to find the longest carbon chain that contains the carboxylic acid group, which we abbreviate COOH or CO2H. The carboxylic acid functional group is the highest priority functional group out of all of the functional groups that you'll be naming. So it is always going to take priority. We're going to find the longest carbon chain with that carboxylic acid group, and then we are going to give the carbon of the carboxylic acid group, position number 1. Then we will name all the rest of the substituents in the molecule. We will assign stereochemistry as needed. And to suffix the ending of the name, we are going to drop just the E of the parent name and change that to oic acid, which sounds a little funny. So let's just kind of write out what that might look like. If we had butane as a carboxylic acid, we would call it butanoic acid, and that is 2 words. There is a space in between butanoic and acid. Let's practice a couple. So let's just go ahead and start by numbering the carbon chain. 1, 2, 3, 4. We see there are no substituents on this particular molecule. So let's go straight to stereochemistry. That is trans, or E. I'm going to stick with trans. It's a 4-carbon chain, so it's a but. It's a butene because of the double bond. The double bond is located on carbon number 2 to butene oic acid. I should add, I forgot to add up here. You do not need to locate, we'll put it down here. You don't need to locate the carboxylic acid group. It is always on carbon number 1. There is no possible way to put a carboxylic acid group in the middle of a carbon chain. The carboxylic acid group in itself has 4 bonds, and one of those bonds has to be to an R group, and there is no room to have a second bond to an R group, so you cannot put it in the center of a carbon chain. This isn't the first time that you've seen this. Don't locate the functional group. We also saw the same thing for aldehydes. We would not say 1-pentanal because that 1 is implied. So same thing with carboxylic acids. Let's do one more example. And let's number this carbon chain. 1, 2, 3, 4, 5. We've got 2 substituents to name. We're going to name them in alphabetical order. That means the bromine comes first for bromo. And then 3-methyl. This is 5 carbons, so it is pentanoic acid. Again, 2 words there. Acid is the second word. So this is pretty straightforward. Sometimes we will have molecules that have 2 carboxylic acid groups. In this particular case, when we have this situation, our longest carbon chain, I'm going to put quotation marks around it because it might not be the longest carbon chain. The longest carbon chain has to go from one carboxylic acid group to the other. So one of them will be at the very beginning of the chain, and the other one will be at the very ending of the chain. In terms of the rest of the substituents and numbering the carbon chain, all of that is going to be normal. For the changing the ending of the name, you don't drop anything at all. So you don't drop anything off the parent chain. Specifically, don't drop the E, keep it there, and instead add dioic acid. Acid is word number 2. And this also is not the first time that you have seen don't drop the E. Anytime we have 2 of the same functional group on a molecule, we never drop the E. We saw it first with alcohols when we had a diol like that, we would not drop the E. This would be 2,3-butane diol with the E included. And we also saw it with alkenes. If we had a diene and we wanted to name this molecule, we would name it as 1,3-butadiene. Oh, that sounds like we did drop the E. Butane diene. No, we did drop the E. Ignore that. I wish there was a way I could edit that out. I don't know how to do that. It is it is unfortunate, but I'm not starting this video over again because it's 8:44 at night and I want to go to bed. Let's do some examples. So let's do this guy right here. So when we number this carbon chain, we're going to start at one of the carboxylic acid groups and just number to the other carboxylic acid group. This is a really simple molecule, but we're going to take the same rules no matter how complicated the molecule is. It's a 3-carbon chain, so this is propane. We leave the E, dioic acid, and again, we are not locating either one of the carboxylic acid groups because the rule that we have to start numbering at one and number all the way to the other, it's implied that they are at the beginning and the end of the chain. There's nowhere else for them to be. Let's do an example that's a little bit trickier. So for this one, we have to start numbering at one of the carboxylic acid groups and go to the other. And when we have a substituent present on the chain, we are going to choose to number in a way that will give the substituent the lowest possible number. So the molecule like this, as it's written, we would want to number it from right to left. What if we had a couple substituents? Let's add a second one on here and see what we do in that case. So if we have 2 substituents, and whether we number from left to right or right to left, we're going to end up in a tie. In this case, whether we number left to right or right to left, our substituents will be on 2 and 5. In that case, we want to give the lowest number to the substituent that would come first in the name, so alphabetical. Ethyl comes before methyl, which means that we want to give the ethyl the smaller number. And again, this is only in the instance of a numbering tie. Our ultimate priority is to come up with the smallest possible set of numbers. So starting with our substituents, we have 2-ethyl, we have 5-methyl, we have hexane, dioic acid. That's a long word. So last scenario would be a cyclic. Now we can't have a ring that has a carboxylic acid group built into it because that's not structurally possible. But what we can have is a ring that has a carboxylic acid group on it, attached directly to it. is on a ring. So before I finish that, let's just draw what that might look like. We've got a ring, and the carboxylic acid group is right on the ring, hanging right off the ring. In this case, so the way that we handle this, we are going to name the molecule as if the carboxylic acid group wasn't there. Although, side note, we are going to include it. We're going to acknowledge the presence of the carboxylic acid group when it's time to number. So the carboxylic acid group is going to dictate the numbering, and then we're going to pretend like the carboxylic acid group isn't there at all, and we're going to name the molecule as if it wasn't there. And then once we get that molecule's name, we're just going to add carboxylic acid to the end. And kind of what it feels like with these cyclic carboxylic acid names, it kind of feels like IUPAC was just tired. Like they just kind of gave up. So let's do this as an example right here. So here it is. So the first thing that we want to do is we're acknowledging that the carboxylic acid group is there, and it is controlling the position of carbon number 1 in this molecule. And then we want to give our ethyl substituent the smallest possible number. So there we go. Then what we're going to do next, now we're going to temporarily ignore the carboxylic acid group. I'm just going to temporarily erase it. We're going to pretend like it's not there. And we're going to name this molecule, even with the weird numbering. So it's 2-ethyl cyclopropane. Oh, pentane, not propane. Pentane. And then we're going to remember that the carboxylic acid is actually there, and we're just going to say carboxylic acid. This is 3 separate words. Again, doesn't it? It kind of feels like IUPAC gave up. Let's do another one. One last one. Okay, so for numbering, we want to give the carboxylic acid group the highest priority, number 1, and then our goal is to give the remaining substituents the smallest possible set of numbers. So that means we want to go to bromine next, so that it can be number 2, and our alkene can be number 4. The other way around, we'd come up with higher numbers. Now we're going to temporarily ignore the carboxylic acid group, and we're going to name this molecule 2-bromo 4-cyclohexene carboxylic acid. There are 2 carboxylic acids that you should know by their common names. By now, you probably already do know them by their common names. One of them is acetic acid. You might not recognize it in line structure, but you would definitely recognize it in Gen Chem condensed formula notation. The other one that you need to know is benzoic acid. And that is the ending of nomenclature for you. You did it.